Evening, everyone.
How's it going?
Not too bad, thank you. Hope everyone's doing all right. My name's John. I'll be hosting tonight. I take it you're all here for the LaTeX workshop. Hopefully, because that's what I'm here for. Just get some stuff set up. Usually I'll hang around for a bit and start at about 10 past or so. Just let the stragglers join, and a lot of workshops and stuff for courses finish at about 1/4 past. So let all those people filter through. Seems like we'll have a decent turnout tonight, which is good. The first few workshops in the start of the semester only had a few people in, so either everyone's super interested in LaTeX or everyone's more comfortable on Zoom. We were over on the Discord before. But yeah, glad to see we've got a bit of a turnout, which is nice. So say hi in the chat. My name's John. And yeah, we'll be learning about LaTeX tonight. I'm just going to try and find a way to share the slides with you guys, just in case it becomes a little bit awkward with my share screen. I take it my second screen shared, and you can see the slides there. And yeah, these things I like to keep them relatively casual, so you know, usual etiquette applies with large groups of virtual meetings. Just keep your mics muted unless you're talking, but more than happy for people to say hi, yell out, ask questions, whatever you like. Just posted a link up in the chat. Should be able to download the slides from there. And yeah, follow along at your own leisure. How's everyone's semesters going so far? I'm only doing one subject at the moment, so I'm relatively cruisy, which is nice. I don't miss the stress of 4 subjects. I don't know how you all do it. Ooh, quantum computing. Nice. How's that? I saw a release that I think it was Intel aims to have, was it 1,000 qubit chip release by 2023 or something? Should be interesting. So I take it most of you are most of you are at Uni Melb, I would imagine. Anyone else? Anyone from a different uni coming along tonight? And I guess I'm with MUX, so I'm guessing most of you probably doing electrical eng in some way, but sometimes we get a bit of a diverse bunch come through. Doing my master's at the moment in, yeah, electrical.
Oh shit, okay. Maybe I'll listen to this guy.
Is everyone complete beginners with LaTeX? Anyone had any experience?
Why isn't it pronounced latex?
Good question. Just is not. I think that's the first thing on the web, on their like official website. And by the way, anytime you're dealing with anything LaTeX, it looks like it's from about the 1990s, the websites and stuff, because it is. It hasn't changed too much, but yeah, one of the first things on the LaTeX website is you pronounce it LaTeX or LaTeX, but certainly not latex. Not sure exactly the rationale behind that one, but yeah, just is. Yeah, Markdown to LaTeX. Well, at least you're in Markdown, right? If you've got some of that sort of the mindset behind Markdown, you'll find the transition easier. LaTeX is, yeah, primarily you're sort of thinking about it like code in a way, and Markdown is a step in that direction. Markdown is quite nice actually, but yeah, certainly the mathematical typesetting, and you learn to recognize LaTeX documents very, very quickly, and anything in academia is pretty much LaTeX, so it's good. The learning curve is a little bit steep, but yeah, this intro will hopefully take some of the edge off of that, and a nice gentle intro. And yeah, it takes a while. I'm still learning new things every time I use it and finding ways to streamline the process. Yeah. All right, we'll get started in a second. I'll just turn something off. All right, we might make a move. So thanks for coming. My name's John. I'll be hosting the workshop, our LaTeX workshop for MUAC and ARP. Thanks for coming along. It's nice to see a turnout. I was delivering my first few workshops of the semester to about one person, which is never never a nice feeling. So it's nice to have a bit of an audience. And yes, the plan will be to upload this. I'll have to chase down the recordings. I'm not sure exactly where they go. I've been handed over the host privileges for this workshop. Assume it says it's being recorded. I'm assuming it's being recorded somewhere. And yeah, the other workshops is just part of our MUEC and ARP workshop series. So we did some MATLAB workshops at the start of the semester. Yeah, there's a couple more coming up throughout. We've got I'm hosting a control systems workshop next week. And I'm also hosting a Git workshop for all you coders out there a bit later on. I think probably after the break. So yeah, a few different events around. The Git one will be, I think I've got it pinned for week 10 or 11. But yeah, keep an eye on the Facebook events and the newsletters and stuff. And if you're not already, jump onto the Discord as well, the MUEC Discord, where all the announcements go there as well. Dates are still sort of being finalized, but certainly next week is control systems 1, which I'm just finalizing at the moment. All right, so LaTeX. It's a mathematical typesetting language, basically. It's used to create absolutely beautiful looking documents that you'll get to recognize. So assignments, certainly tests, exams and stuff, anything to do with, you know, engineering, mathematics, academia, will be written in LaTeX. The basic outline of today, we're just going to have a quick talk about what we do with LaTeX and how to get into it. And then that'll probably be the first hour. And the second hour, we probably won't go the full 2 hours today. The second bit, we'll just get stuck into writing some LaTeX. And because that's the only way to learn, really. I will share the Discord link for you later. And yeah, do a bit of a spam at the end of some stuff. So hold tight for that. And yeah, we'll be covering the, yeah, sort of just writing and getting stuck into some LaTeX. So why do we use LaTeX over Microsoft Word? If you've seen the meme of moving an image in Microsoft Word and everything shifts down 10 billion pages and goes around and sirens going off, you don't really get that with LaTeX. Things look much nicer with LaTeX, especially any math stuff. And as your document complexity goes up, LaTeX just becomes the way to go. And yeah, certainly if you're doing anything serious, you want to be doing it in LaTeX and moving away from Word particularly. Although I will say that the capabilities of equation editor and stuff in Microsoft Word have improved a lot. And I think you can even write LaTeX in Word these days. We can use LaTeX and integrate it with our workflows, particularly like data processing, things like that. If we've got tables, if we've got you know, figures coming out of MATLAB, we can sort of automate that whole process, and you'll find your own workflows as you use LaTeX more and more. But yeah, it can simplify that workflow a lot, which is nice, and create that nice document for us. You can use it to actually draw figures and create figures directly in LaTeX, basically in a coded style. You code where certain points of figures come up, how they're labeled as, what the colors are and whatnot, which is nice. You know, it sort of puts all that control into one spot in a sort of coding style, and it makes a lot of sense for some of the stuff that we do. If you're in a LecEng, it'll create, well, you can get it to create circuit diagrams nicely for you that scale nicely and just work nicely all in LaTeX. There's links to these different packages at the bottom. The circuit one's called Circuit-Tix. This one for drawing figures is it's sort of PGF, but it's referred to as Tix, T-I-K-Z. So that's why this one's called Circuit-Tix, because you're using a similar package to create circuits. Beamers or Beamer class is sort of like templates, and that's what you can use to create PowerPoint style slides. which is, you know, you might recognize this, the format of this, this presentation itself has been created in LaTeX using Beamer to create that. So it still comes out as a PDF, but it's got things like navigating through hyperlinks and whatnot, and you can get simple little animations for when things appear on the slide as you click through, in the same way that you can in a PowerPoint presentation. It's sort of, yeah, I don't know, that can be a little bit tricky, especially if you're new to LaTeX. I wouldn't be jumping straight into doing a PowerPoint presentation. PowerPoint's relatively good at what it does. Exams, as I said, you'll start to recognize things that look like LaTeX, and these sort of exams, just, yeah, they look like they've been written in LaTeX, which they certainly have been. You can have your code directly in LaTeX with syntax highlighting, depending on the language that you've got. So that's really nice if you're presenting code to, you know, to display it. And most importantly, a couple of cartoons about it: trustworthiness of information by file extension. .tex. So this is a file extension of a LaTeX document, is .tex. So certainly .gif is not very trustworthy. And your paper makes no goddamn sense, but it's the most beautiful thing I've ever laid eyes on, certainly is. So yeah, just LaTeX is very nice, and what we want to be doing for sort of, yeah, any engineering, any maths. Right, so how do we get started? Now, I like to talk a little bit about how LaTeX does its thing, which I'll talk about in a second, and that will make some of this stuff make sense. Essentially, there's a couple of ways that you can work. One is online. I've been working using Overleaf online lately, and it's quite nice. Usually I work offline, which we'll talk about, online versus offline. If you're the sort of the person that likes to keep a hold of all your files and don't like cloud storage and all that sort of stuff, working offline might make a lot of sense for you. If you're working on a collaborative process, particularly Overleaf, I found is quite good. So on collaborative assignments, I've been using Overleaf, which is quite nice. So we'll talk about that. What we'll aim to do today, because it's a relatively short workshop in terms of content, most of it's just doing things in LaTeX, we'll spend a bit of time getting offline stuff sorted out before we, yeah, basically we'll switch to Overleaf if you have any issues getting the offline versions up and running, or you don't want to. Overleaf's a good way that you can just jump in and start doing it straight away. And if you're with UniMelb, yeah, we have a campus subscription to Overleaf, so you've got the full package there. So what is LaTeX? Basically, there's a couple of different ways that we work through and the LaTeX process works. So we start by writing a plain text document, so a .tex document, and you can do that using any text editor you like. It doesn't matter, right? So you could use a Notepad, any code editors that you got, anything like that. Just any way to write a .tex document with that file extension. Then what happens is that plain text document, we compile it just like we'd compile code. So once we compile that code, there's a number of ways you can do that. So by the command line, if you're used to working by the command line, you can compile your text document by the command line, or sometimes there's different ways you can do that. And then once you compile it, it's going to spit out on the other side of the compiler certain other files that are associated with the compilation. One of them, and the most useful one, is the PDF document. So the rendered text in the nice format of PDF that you can then get and submit like you would an assignment. And there's some other associated files that come out of the other side of the compiler as well. You'll see some things like .log, .ogs, so .aux, you know, what's some other ones? I think .out you might see, and all those different files go into creating that nice document, because LaTeX does like things like cross-referencing within your files. So like figure 1, figure 2, if you reference that in your text, tables of contents with hyperlinks that'll take you to the different sections. It takes care of all that. And to generate that, it needs all those other files. We don't usually interact with them in any way. but they are there. So you'll see and recognize those. So whatever way you're creating your LaTeX documents, that's the process that's happening. A plain text document is being compiled by a tool, and then out of the other side of that comes the stuff that we actually use, the PDF. If you're working online, so on something like Overleaf, that process is just happening on a server somewhere. We don't have to deal with it, and it's just gives us a window to edit the plain text part of it, the code style part of it, and then it will display the PDF part of it as well, and then you can download that. So it's still happening somewhere. It's not you know, something different happening. It's all the same thing. Plain text being compiled and then a PDF coming out the other side. So working offline, that means that we need to actually get a hold of the program that compiles LaTeX documents. And that's what's called a LaTeX distribution. So if you want to work online, we're going to have to download some form of these distributions. So if you're on Windows, I recommend Bibtex is a good one. So I think I'll post that link up. Here's a link to download the Bibtex compiler. They all do the same thing. It's just about how they, you know, where you go to download it. And if you, sorry, that was a MacTeX one that I just pasted. If you're on OS X and Mac, you want to get the MacTeX distribution. And if you're on Windows, probably the Bibtex distribution. And I haven't done it in a little while, but if you follow those download and installation instructions, that should hopefully get the command line compiling software set up for you. So that's one part of it. The next thing that we need, because it's not often convenient to write code or write the .tex document in like Notepad or something like that, or text edit. We often work with an IDE. So that's these things here that sort of combine all the interaction into one. They combine the editing of the document, and the compilation is just like a GUI click button, and then that'll reach out to your text distribution and compile it for you, and then display you the PDF. So that's what these third-party editors for. They're like the particularly Text Studio and Techmaker will sort of have everything in one spot for you. I'm not sure about VS Code for LaTeX. I've never used it. Certainly you'd be able to write the code part of it, but in terms of compiling it all in one spot, I'm not sure that Visual Studio Code can do that. So Techmaker is the one that I use. So I'll quickly post up a link to Techmaker. And I'll talk a little bit about Techmaker and show you that. So you need two things, right? You need, well, you technically only need one thing. You need some sort of way to compile the document, which is the distribution. And then you need some way to edit the file that you're using. So I would recommend Techmaker for that one to do that. So I will pull up Techmaker and show what that looks like. So this is the GUI interface for Techmaker. And if I open up a new document, it gives me somewhere to write certain things. And then basically, once it's set up properly, you hit the quick build button, or the way that I've got it set up, you'll hit the quick build button. That's going to run the compilation, and then the PDF appears on the right-hand side. So if you're working on an offline version, or if you want to work on an offline version, certainly start to download your distribution and download some sort of editor, and I recommend Techmaker. If you don't want to do that, and if you want to take the online route, we'll switch over to Overleaf. And that is just Overleaf. And yeah, if you're at Uni Melb, sign in with your University of Melbourne email, and you'll have the full set of tools. And this is what Overleaf looks like. Just access through the browser and all your stuff happens there. So you'll click on new project and we can start a blank project. And create that. And luckily or conveniently, Overleaf gives you same thing. It's got a place for editing the plain text format, and then on the right-hand side, it's got the PDF that's generated, and it gives us a start to sort of set up the document as well. So there's a little bit of setup to create the document itself, and I'll just take this back to its most basic form. Okay, so that is a very basic LaTeX document there. So we can do that in the in Overleaf. So if you want to work online, jump on Overleaf, try and get something like this working for you, and we'll expand on that. And if you're working offline, we'll do the same thing in Techmaker as well. So I think in the slides, we've got something like this here. So our first Hello World document, this is what we need to do to get that going. So whichever method you want to use to write your LaTeX, offline or online, let's try and get this Hello World document going, and we'll work through any problems that people encounter. And just sing out if you do run into any problems. We'll try and solve them. So first thing, this is called a preamble. So the thing that you start with, and that's called a document. First thing you need to do is define the document class. A lot of commands are started with a backslash. So document class article, and you want to begin. So things usually happen within a begin and end block. So we can begin and end our document and say hello world. Then I need to save it. Yep, that's fine. So because of all the sort of chaff associated with LaTeX, you want to keep everything in a nice folder. If you're working offline, I usually call it just tech or something, or LaTeX for a particular project that sits separately from other stuff that you're doing. That way things stay sort of clean, because otherwise you end up with a few things. So for example, for this stuff, I'm going to create a new folder called send to LaTeX workshop. Create that, and then within that, I'm going to call my create my tech document, and that's called workshop.tech. And save. And once I've got that, I can hit quick build, and there's my PDF coming up on the right-hand side. And Techmaker does take a little bit to set up, so sing out with any problems. Particularly quick build is the option that you're looking for here, which there's a few commands that go into actually creating a PDF document, and quick build itself does a nice job at sort of making that a nice, easy process. So quick build in Techmaker, and then you want to have view PDF on the other side as well. That should get it set up similarly to how I have it. And as I said, with Overleaf, it's super easy. They've got basically the same workflow set up. Writing your text on the left and your output coming on the right. And just so I can see if you're ready to move on, if you've got this Hello World document coming up, just in the Zoom chat or the participants window, you can click on the little tick icon for yes. Just if you've got up to that stage and you're ready to move on, just throw up that little tick icon, and I'll keep track of how everyone's going, and yeah, move on when a vast proportion of us are up to speed. I'll talk a little bit about the contents of that folder now that I've generated my document. So here's the folder that I created where I saved that document I just created on my local machine. And there's a few files here that we've got. So there's workshop.tech, which is, you know, if I'm working in the Mac tech world, sorry, in the Techmaker world, that's the plain text one. So I could open that up with any text editor that I like, right? It's just plain text with a .tech extension. You can edit that however you like. There's a .log file. We can have a poke into that and see. It got some output coming from the compiler when Techmaker itself compiled it, which is super handy. Errors will come up there. We've obviously got the PDF document coming up, which is nice. That's the thing that we all want. And I've also got this .aux file, which holds a command relax. I don't know whether that's just being cheeky or whether it actually means something. You never really have to look at the .aux file. That will hold all of the cross references between your document. So as your document gets more complicated with referencing figures and stuff, that auxiliary document comes in more handy. And because of that workflow, because a compilation creates files that you then sort of need to feed back in for cross-referencing, sometimes you'll see a little note in the log file that says you need to rerun the compilation. So you need to quick build again, or you need to recompile to get all the references working properly. So keep an eye out for that. Sometimes you'll need to hit that compile button a few times in a row to get all the references to sort themselves out. So just be aware of that. All right, so getting a few ticks coming up, still waiting on a few. Don't forget to throw up that green tick in the Zoom participants window when you're done. If you've got that Hello World document, if you are having troubles or you're just waiting on downloads, just yeah, let me know of any problems that you're having. Happy to work through them. Setting up a new platform is always the hardest step. And once we're all sort of up to the same spot, we'll keep working on through. If you want to go ahead, feel free to keep getting some of this stuff going. Honestly, getting familiar with, how do I even interact with LaTeX and how do I get started up? Then yeah, that's often the biggest barrier. So feel free to zoom on ahead if you need to. That's not a problem. Yeah, so sometimes getting the view of Techmaker itself set up properly differs when you first get it set up. I haven't set it up in a long time, but perhaps under the view options, you can tick and untick some of the views. So I think, can't remember which one. So certainly you want the PDF viewer coming up. Will help you view your PDF. But yeah, I haven't really changed mine in a little while. So if anyone has any issues or anyone solves the problem that other people are running into, Ventila, when you run it, can you compile a document? Like, can you find the spot on your machine where it's meant to be outputting to, and does it generate a PDF? If so, then that's just a view issue. But if you're having troubles compiling it, that's a bit of a deeper issue. Okay, Mohammed, are you using Techmaker? I think make sure you've created a new document.
So do I have to create a new document first before tapping in the code?
I believe so. I think so.
Yeah, I can get to work on Overleaf, but I can't get to work on Techmaker.
Yep. So I'll just go over. There's two steps to getting LaTeX set up on your computers to work offline. The first thing you need to make sure, and this is, I think, Mukul, if you're having issues compiling it, you need to make sure you download the tech distribution. So that's either Tech Live, Mac Tech, or Mic Tech. I'll paste those links again, or if someone finds them for me, they're a little bit up in the chat. It's not just LaTeX. You need to download the tech distribution as well. Techmaker will only allow you to write the code and view the code. Techmaker itself doesn't take care of the, doesn't take over the, sorry, just did that in a private chat instead of to everyone. Techmaker itself doesn't do the compilation. It only reaches out to the compiling tool. So if you haven't installed the compiling tool, which is the distribution, Mic Tech, Mac Tech, or Tech Live, then it won't work. So try that.
Yeah,
get that installed.
That'll take a while for me, but I'll just do it on Overleaf for now.
Yeah. So yeah, for people getting that error, try and, you know, if you're already 100% sure you've installed the distribution, let me know. We can try and sort it out. But if you haven't, make sure you get that tech distribution installed, which is separate from Techmaker itself. And yeah, in a little bit, I'll just say if you haven't quite got it up and running, we'll switch over to using Overleaf, because yeah, getting that set up can be a little bit of a pain, and Overleaf takes a lot of the issues away. I had a question about whether we'll be going over Bibtex. I might if I have time. It's certainly very useful. It's not technically a part of the workshop. I probably would have included it if I was writing this workshop again. It's very useful. So yeah, we might do some Bibtex stuff if we've got time. Nawaz, I've never used VS Code for writing LaTeX. Certainly, you'll be able to write the source part of it. You know, it's just a tech editor, a text editor at its core is VS Code. I don't know about the compiling of LaTeX documents though. I've never tried. If anyone's used VS Code for that, speak up. But yeah, I don't have experience with that. Sorry. And yeah, I'm a little bit rusty on the installation and setup side of things because I haven't had to do it in a long time. And even updating, like LaTeX doesn't update that often. It's been around for forever and it's prides itself on its stability. So yeah, once it's going, you're pretty much set. So my apologies for not being more well versed in that process. But yeah, with Overleaf and things like that, it's pretty easy to get up and running. All right, so last call out for green ticks. If you've got the Hello World document going and you can see the PDF, chuck them up so I can gauge how we're all doing. And if you think you're struggling to get it up and going, I'll direct you to Overleaf for the remainder of the workshop so you can follow along. And we'll try and sort out some specific problems at the end of the workshop if you're really keen to get the offline version up and running. So jump onto Overleaf if you're having problems. Posting that link up again. And yeah, whether you're working in Overleaf or whether you're working offline, hopefully the process and what's going on behind the scenes makes sense. And we're all sort of dealing with similar things, writing the source code part of it and viewing the PDF on the other side. That's where you want to be with your workflow for now.
How do I run the document?
Which one are you using? Are you on Overleaf or Techmaker?
Techmaker.
Yep, so the command that you're looking for is quick build. So depending on your drop down, you might have to drop that down and select quick build. There's a lot of different options here for the exact thing that it does when you hit this button. Quick build is the one that you want. So you write your code, make sure quick build selected, then you hit this, this run button here. And then you also want to make sure that view PDF is selected as well, or at least you have the PDF viewer appearing on the right-hand side. So check under view and make sure that's checked off there.
But when I click run, it's giving me an error.
Yep, what's the error?
It says could not start the command.
Yep, and you sure you've got the tech distribution installed?
Yep.
Yep, okay. Potentially, can you open up a command console at all? CMD, or are you on Mac or Windows or Linux?
Windows.
Windows, yes. So if you open up CMD, the command prompt.
Where is it? I'm lost.
I think if you can hit Windows key R, will bring it up from memory. I'm a Mac user myself, so otherwise, just at the start menu, if you type in CMD for searching through your applications, that should come up.
Nope, it's not coming up.
Or command, maybe.
Command prompt.
Yeah, command prompt, that's the one.
Yep.
Yep, and then if you type in, I think it's PDF LaTeX. So just type in PDF LaTeX, all one word, and press enter. And does the same error come up?
Nope.
What happens?
It says this is PDF tech version, and then there's this version number.
Okay, cool. So that means you've got the correct compiler installed. It probably means that the references to that is not quite set up. Did you maybe try what am I trying to say? Maybe try quitting out of Techmaker entirely and then opening back up. It could be running in like a subshell, and the references gotten mixed up if you didn't install them. You installed them in a quite sort of different order. Otherwise, I think the exact settings you can find under the Techmaker preferences. They look a little bit, what's the word? Confronting. But essentially, this is the command that PDF LaTeX is running behind the scenes, and you can see the commands that quick build is using. So PDF LaTeX plus view the PDF happens when I run the quick build. So if the command works, yeah, it's probably some referencing issues going wrong in Techmaker. Give that a try. If not, jump on Overleaf and we can work on, after the workshop, we can try and get you up and going offline.
Thanks.
All right, let's move on, guys. So if you're keen to follow along and you haven't got it going already, jump on Overleaf and follow along using the online, and we'll dedicate some time after the workshop to sort through issues. Okay, so As I said, the first part of your document is typically called a preamble. Anything that happens before the begin document is what we call a preamble. So all the things up there are about getting your document ready and set up to display things and sort of make things happen the way that you want. So you can sort of think of them like libraries or packages. If you're doing code, they're called packages in LaTeX. So if you're, you include different packages using this use package command, and depending on the options that you set, they can change the way that your document gets displayed and compiled. So we'll copy this one. We'll use the package geometry, and we'll just set some margins on that one. So if you've got tab completions, that can be handy to sort of skip your way through. And sometimes, yeah, I don't remember too much of the commands. I've got my own preamble set up that I've got set up the way that I like it over all the years. And I just copy that preamble between documents and have it set up as a template sort of thing. So I don't need to do all this setup every single time. I can just go straight to writing the content. You can set a title, an author, and the date. That will make a title page appear nicely when you do it in this method. So yeah, just in the preamble, you set the title. My workshop document. I'm the author. The date is today. And then in your document itself, you just use the command make title. And then when I run that, it's automatically generated me a nice title page with the content and with the correct title, author, and date. So you can have this set up in your preamble all the time, and you don't need to change it as you need to. You just make the title as you want, like this. So that's how title pages work. What do we got coming up next? We'll move on to essentially, I think this, let's have a look. Yeah, it sort of goes in a direction that I don't quite want to go into yet. So we'll just work on sort of starting off a document. If you want your title page to appear on a new page, you can use new page. And then we've started our document down on the second page here. Typically, you'll start off with the section command. Section introduction. This is the introduction. Okay, and when we use the section command like this, and we give it introduction, that's going to create the introduction section like this, and we can just start typing in there. As we do more sections, start adding more sections, LaTeX formats it all nicely, sorts out the numbering for us, and keeps everything looking all nice. So that's how we work with sections. If you have subsections, obviously we have the command subsection. Okay, and LaTeX will start with the point style of formatting for sections and subsections. So 2, 2.1, 2.2. If you need to go a level deeper, there's subsection, which works in the same way. And yeah, you just start structuring out your document using sections, subsections, and subsections, typically for the sort of stuff that we do as engineers. You know, you can write books and stuff in LaTeX where you can use things like chapters, but because we've got this set up as an article, document class is an article, this is the way that we sort of want to go with sections and subsections. Okay. If we need to do some basic formatting, there's bolds, italics, and underlines with the commands. So we'll do some of that. With TextBF for text bold font. Text IT for italics. And text, what's underline? I don't use that one much, underline. So you just include the text that you want within the command of TextBF. So these are sort of called environments. When we do a backslash something and then open up a curly brace, so we'd say this text exists in a TextBF environment. So if I compile that, we've got our nice formatting there for those. I will get on to some, including graphics. Yeah, we'll do the graphics next. So to handle graphics, like LaTeX natively doesn't do it, we need to include some other packages. So typically you can always include these in your preamble, use package graphics and use package graphics X. Two useful ones there. So I'll go up to where I start including my packages. I'll put those in, use package graphics, use package graphics X, or graphic X, sorry. And then to do that, let's see if I can get an example image. I'll just take a quick screenshot of something that's not going to be confusing. Okay, so with an image, once you've got the image as a JPEG or a PNG or something, what you need to do, you need to first of all include that image in your working directory for the LaTeX project. So in this case, I need to go to where my screenshots get saved, or you know, if you're creating this figure through MATLAB or something like that, you just need to make sure that goes into the working directory that all your LaTeX folders go into. If you're working on Overleaf, what you need to do, you need to upload that image. So you click on upload and select the file from the computer, and that is going to upload it into the, let's see. So when I upload this image into Overleaf, that's going to put it in my repository of files that Overleaf has access to. Once it's there, it's going to work in the same way. So just making sure that that is in your working directory. And then what we need to do, we need to go start a new figure environment. So begin figure, and I'll talk about what all this stuff means in a second, but what we need to do, begin and then figure. Right, so it's an environment, so it starts with a begin and an end. The H, so this is where basically you specify where this image is going to appear in your document. I believe H is short for here. So you imagine where you're including that block of code in the source, we want to render the figure here in our PDF document. So that's what the H is for. If you don't include the H, LaTeX itself is going to decide the best place in the document where that figure can go. Because often, you know, it'll try and optimize the layout and where things go. If you're having trouble with, you know, your figures are not appearing in the right space, you want to try and look at the options for this one. So there's things like H, HT, H and then an exclamation mark, or HT, BT, I think. That's where you specify that thing. And that's it's called options for this figure environment. So we want to include the figure here. We want our figure to be centered, so we use the centering command. The next line itself includes the graphics, and we can set the width or the scale in a few different ways. So in the square brackets for this one, width equals 0.25 text width. So this \text width, it basically LaTeX knows how wide your text is within that document. And then the 0.25 is just a multiplier on that. So we're saying this graphics needs to be 0.25 times the width of the text. Additionally, you can use the scale command like that. And then you just type the name of your the image that we had. So I called mine island.png. We can include a caption for that image if we want to. Caption, a nice island. And then we can also label this image for referencing later with the label command. So label, and then you don't need to use fig and then the semicolons. This is just a nice way to sort of keep your images and labels and references organized, right? So if you label with all your figures, started off with fig and then colon and then whatever you want to call your image reference, that's a good way to keep all the figures together. You can label equations and you can have those as label EQN colon and then whatever you want to call your equation, or tables like TAB for tables is a good way to do it. You don't need to though, as long as it's got a unique name, it'll figure it out. I'm not a huge fan of calling it image one. The best way to use references in LaTeX is to call it something descriptive, right? The screenshot of island, you know, maybe a bit shorter than that. But essentially, I'm not a huge fan of this because LaTeX doing the job of keeping track of whether figures are like figure 1, figure 2, figure 5 and all that. You want to be descriptive with something that makes sense to us as humans rather than just image 1, image 2. So I'm a fan of calling it something descriptive. Okay, let's try and render this and see what happens. Okay, so you can see here, my image isn't appearing on the page where I put it in. So I put it in my second subsection. So in the code, my image appears here. In the PDF document, it's rendering it down here. It's absolutely massive. So I can adjust the scale for that one. I might use the width and I might make it to be the width of my text. So now we're looking a little bit better. And because it's a reasonable size, it's appearing in the right spot. If I don't include that H, let's see if it puts it somewhere else. Yeah, so it's put it at the top of that page. So LaTeX thinks for some reason that the top of this page is a nice spot to render that image, which isn't necessarily right. So H is a good one to have if you want that image to appear where you've got it appearing in the code. Like that. Okay, so if we maybe make that smaller, half of my text width. that's working in the way that we want it to. And you can see below, there's my figure 1 and my nice caption there that I've put in the caption. If you need to reference that figure, as you can, so this is just in my main body text, as you can see below in figure, and then, you know, the bad way to do it would be in figure 1, right? That's defeating the purpose of setting up all these references. I mean, LaTeX has named it figure 1, but what happens if later on we go and drop in a figure above it? All that's going to change. So you don't want to hard code your references. You always want to reference them. So \ref, and then you're going to have the reference that we put in the label. So labels tag it when you create it, and references will reference those. And then when we run that, LaTeX has rendered it as figure 1, but that's always going to match the way that we have it appearing in the document, as long as you do your references nicely and set them out like that. And that's why descriptive names as well is good as well. So you can just glance at the text and know what the figure is going to be, and just let LaTeX worry about how it's going to number and name them. Okay. That will probably do us just for the moment. I like to take a bit of a break. So we might break for about 10 minutes or so, and then we'll come back and we'll start getting into the math side of things, which is probably the main sort of thing that you'll be doing and using LaTeX for, is rendering mathematical equations. So we'll get some practice with that. So we'll have a break for about 5 or 10 minutes. I'll be back in maybe 5 and answer any questions that you have. And then, yeah, after about 10 minutes of break, we'll launch back into it. Thanks for, all right, I'm back here. I'll give it a few minutes. Good to see you're all answering questions. And yeah, certainly Google's the way to go. For getting, you know, I'm Googling things all the time to get it to do what I want to. So certainly no worries with that. Yeah, so not sure how to move the label with the image. You might want to have a look into the flush left environment. Let's just do a quick little test of some things. I'll do it blind, I won't try and Google. So there's my caption. Let's try and go in flush left and put my caption in there. Nope, that didn't work. What about if I do it in the caption itself? Honestly, I've never had to. Things look nicely centered, I think. There's a couple of ways to achieve things. Yeah, if you want two images side by side, there's a better way to go. The mini page or sub-figure environment is the one that you want to have a look into. Sorry. And I think there's an example in the slides that use mini page. So that's a way that you can start having a little bit more control about exactly where your images sit with the mini page. And yeah, honestly, I think there's quite a nice package called Subfigure, which, like, you know, if you've got figure 1 and then like figure 1A and figure 1B, and they'll appear side by side, that can be quite nice. But yeah, it's more about knowing exactly what you want to do. So jump on Google and, just Google LaTeX, how to put two images side by side. Will be the best way to go. I won't fudge my way through it. I honestly just usually leave stuff in the middle, unless you're really, really sort of trying to hit a page count in terms of like, or you've got to condense stuff in, or really trying to lay stuff out exactly how you want. Usually the default works pretty well. So I tend to just leave it. Okie dokie. So let's start having a look into some mathematical type stuff. LaTeX has got a decent amount of default mathematics stuff, but typically we'll include the AMS Math package in our preamble sort of all the time. Use package AMS Math. And that's going to include a lot of extra useful mathematical stuff for us to use. We've got a few different environments to start putting equations in. We'll talk about how they get used. Equation is one. This is spelt wrong here. Yep, exactly. Thanks, Breeze. Not equation. Align is the one that I probably use the most. Align is part of the AMS Math package. I don't think it's part of the default LaTeX distribution, default LaTeX. I think equation is though. The difference is between numbered and unnumbered environments most of the time, and we'll see how they work in a moment. So I'm going to do a quick example of some maths. Let's do it in the introduction, because all good maths happens in the introduction. So begin equation, and then I'm going to do y equals mx plus c, and just render that out. Okay, let's get a bit of extra zoomage happening so we can see. Oops. Okay, so there is my linear equation, my y equals mx plus c, and you can see it's going to number that with number 1. So that's an equation environment. If I do an align environment, begin align, and f of x equals ax squared plus bx plus c. There is my equation, my second equation, which is in an align environment. So they will appear like this. Some text. So they basically, equation and align are quite similar. As I said, equation is part of the base distribution. I believe align is part of the AMS Math package. I tend to use align more. Equation is sort of, you'll see more old school people using. I think AMS Math is relatively new. Align I find is better, because if we need to do 2 lines, equals x minus 1 and then x minus 2. If I want to do multi-lines, first of all, to break a line in an equation, to break a line in an equation, you use double backslashes. But if I render this out now, we've got, it's split over 2 lines as we like, but my equal signs haven't aligned, basically. So that's the point of an align environment. we can use the ampersand character. So shift and then number 7 on your keyboards will include the ampersand character. And that's going to tell LaTeX in an align environment, where do we want things to line up? So they're going to align it where we place that character. So if I render that now with my 2 ampersands in here in my align environment, all of a sudden now my equal signs have aligned nicely. I think if I try that in a equation environment, I don't think you can use alignments in equation. As I said, I rarely use them. This doesn't mathematically make sense, but whatever. Yeah, misplaced alignment tab character, so it just doesn't work in equation. The other thing is starred environments. So we've got numbered versus unnumbered environments. So if we include stars after them, it's going to get rid of these referencing numbers. So a lot of the time you don't want to include a reference to every single equation. So if I put this instead of an align environment, if I put it in an align star environment, the number referencing from my equation has disappeared, which is what you want most of the time. So most of the time you default to align environments. If you want to only include references to some lines, so say for example, we go back to our regular align environment. I've got to match up align and align star, so make sure they both say the same thing. If I only wanted to number reference the last one, on any user align environment or a non-start environment, but you just include the command no number at the end of each line that you don't want to have that number on. So that way it will render it out without the number. And then if I wanted to reference that equation, you drop in a label on that line, EQN for nice referencing, so label equation, and then factored form or something like that, keeping with a nice references equation. And for referencing equations, I use EQRef for equation reference, and that's going to put brackets around the reference of the numbered equation in the document. And so yeah, that's how you would reference that. Compile. And just a note here about the warnings down the bottom. So reference equation factored form is undefined. And it's like, well, it's not, but that's what I was talking about, the feedback between the different output files and the input to the compiler. We just need to run this twice in a row to get those references to sort themselves out. And all of a sudden those warnings have gone away and everything's coming up nicely. So that's how we would reference an equation. And yeah, as Jaden mentioned in the chat, we can do fractions. With \frac, and then you need 2 curly braces, the numerator, and then the denominator in the second set of curly braces. And then, yeah, you can't really see it at that scale, but that's obviously made a nice looking fraction. One thing that I'll note, if we wanted to say include brackets around this fraction, if I just use regular old brackets, let's have a look at what happens. And I'll just get a bit of a zoom on that. That's not the one. Okay, so if I include just brackets, just curly brackets in the code, it doesn't really make the brackets look very nice around fractions. What you want to do, you need to use a slightly more long-winded version of saying do me a bracket. So you need to go \left and then open brace, open curly bracket. And then for the right one, you need to go \right. And if we do that, LaTeX is going to figure out the correct height of the brackets to use that match that nicely. If you didn't want curly brackets, you can just do square brackets instead. We'll do square brackets. I think you can do braces as well, but I think you need to reference them slightly differently. But yeah, depending if your brackets aren't looking right, like you can get away with them in some cases, like up here where I did my factored form, I just use regular old brackets. I didn't need to use \left and \right brackets, but they can help the size be right. And then, yeah, as Jaden helpfully said, there's a begin matrix, there's B matrix for bracketed matrix and things like that. So it's all there for maths. You just need to look it up and know what you need to do. That's sort of how to put what's called types of display math, which will like break your text and put the math on it in its own little bit. Sometimes you want to do inline math for little snippets. So sometimes we want to do inline math like, and then we include inline math between two dollar signs, like this. F of t equals, let's do something like a dot. I don't know, just making stuff up to show you some different commands. So within a single dollar sign, we'll get inline math, and then that's going to appear in line at a nice height. So dots for over dots like derivatives, you can do, I think it's like over bar maybe, or over line. There's another one that pops up somewhere. Again, you just need to sort of know what you want to achieve, like a mean X bar. If I instead do two dollar signs instead of one, that's going to put it in its own little own line, but it's not quite as full on as a line and equation environments. It just sort of reads like a line of text, so you can fit more in for small little referencing. But it's not designed for big long equations, like working through algebra and things like that. You'd use a line for something like that. All right. We've covered sections, numbered and unnumbered. Well, we didn't cover unnumbered ones. So again, you can use, if, for example, we didn't want numbering for our different sections, you just use section star, and like section star, if we only want one of them, some of them to have numbers, some of them not to, you just include the stars around the ones that you don't want the numbering, in the same way that we did aligns and align star environments. So you can see here, it's not doing numbering here because we don't have a number for the main body. It's gone 0.1. So you can control your numbering in that way. You can also control which number appears. Like if you wanted to say, for some reason, start at section 5, I don't remember the command, but it's like set number or something like that. You just have to look it up. I've forgotten. But you can do that. You can do anything, really. Sometimes it's a little bit tricky, but you can do anything that you like to get it appear how you want it to appear. Okie dokie. Tables. I won't go too much over the tables, but this is how you do them. Begin table and begin tabular. It's just the way you do it. C is for whether each column is center aligned. So you can do L, C, or R for left, center, and right alignment within the table. Often these days I'm using online or Excel add-in, which I think is mentioned just here. Yeah, this one, Excel to LaTeX. It's an add-in to Microsoft Excel that you can select a set of cells and say, generate me a LaTeX table. That way you don't need to write all of this code by hand. So that's super easy. Or there's plenty of stuff online that will do something similar, where you can paste up a table and it will generate the LaTeX code that will make that table. They can get a little bit of getting used to, but at its core, this is the sort of format they're going to be looking at. So ampersands for dividing up your columns, and double backslashes for breaking lines to the next row. Some more packages here. So AMS symbols, so you can get more math symbols that aren't included in the base package. So this one, again, is pretty standard. You'll probably want to include that in your preamble all the time. PDF pages, you can select bits of PDFs and include them into your document. SI unit ticks, so haven't actually used that one before. Looks interesting though. SI unit formatting and decimal alignment in tables, looks really good. CSV simple, read in CSV files to automatically create tables. Again, haven't used that one too much. Book tabs for nice looking table dividers, fancy header for documents. Basically, yeah, a lot of times if you're doing something complicated, you want to have a look and see if anyone's made a package that's going to make your life easier. I've used one that's for like creating a nice directory tree structure, making that look nice. I think it's called dir tree, DAR tree. Some other stuff, don't think I've used these ones too much. So Iguanatech, Inkscape, Microsoft Visio. Yeah, it's just some different stuff. People have been using LaTeX for years and years and years. So there's usually a solution for whatever problem you've come across. Fun little one to get this weird looking LaTeX, you know, their logo, if you will. This is the introduction to you do backslash and then LaTeX. So they've inbuilt a command. Why doesn't it work? Maybe it's under AMS Simd. Is that right? Thank you. Yep, capital A, T, N, X. And then that should hopefully, yeah, don't use that one often. Yeah, there's that little LaTeX logo thing, which can look like you know what you're doing. Sweet. And yeah, if you're working in Techmaker, obviously if you need a quick hint for the different types of symbols down the left-hand side, there's a list there, or yeah, someone linked a list of mathematical symbols before, which can be super useful. And yeah, oftentimes you're not doing anything too fancy, and if you start using enough, you figure out what you need. Right, definitely Google, always on Google. You know, it seems a bit counterintuitive. You're always having to Google, how do I do this, rather than just using Word where you can do it all. It can seem a little bit counterintuitive, but yeah, I think the benefits of LaTeX far outweigh that. When you're getting fancy and have been using it for a while, like I'll just quickly open up my, where's one of my, do I have a header in there? No, probably in, yep, so this is my header, or my preamble that's got all the stuff that I need, that goes into every document. I've got some stuff in here. I've also got a lot of stuff that makes my life easier. Like instead of, if you wanted to do like a derivative, instead of writing like d on dx all the time and having to set up the fractions, is to set up the commands so that they're all nicely easy for me. The, you know, derivatives, differentials, all that sort of stuff, all my bibliography set up. It can just be useful. So you start building up your preamble, and that works for you. I'd say I just had a question about how long before we start to see the benefits. I'd say, it's as soon as you submit your first assignment in LaTeX, I'd say that's a benefit. If you're doing anything big with lots of references and anything with maths, I'll come to LaTeX. It does take a little bit. I mean, it's been a little while for me, honestly, since I've gone through that learning curve, and it is quite, quite confronting the first couple of times, especially when you had that pressure of having to do an assignment and you're trying to get, your LaTeX document just won't compile. But yeah, I'd say like within a week or within one assignment, you will be getting more and more comfortable. And the next one will be easier and easier. And yeah, probably within a few weeks, if you're doing it like that, I think you've ironed out a lot of the kinks, and that's essentially what this this workshop's for, is to take some of that pressure off the first step into it and getting everything set up, and knowing what's going on, and getting a bit of practice going in. So what I'll do, there is a few exercises at the end. If you're after a challenge, try and copy this formatting and get these coming up like this. So you're going to get some practice doing powers and brackets and things like that. Some symbols. If you're after a bigger challenge, you can try and find a different equations to typeset and get coming through. But yeah, it's about just knowing how to format this sort of stuff and solving the challenges that come up, like, how do you do a subscript? You do underscore, and then if it's just one character, you can just do that character. But if you need multiple, you include anything in the underscore, anything that you want subscripted in the curly braces. Similar thing with the power. You use a caret like you usually do to the power of, and in that way you can use curly braces to get a few things. So have a try and format some of these. I might choose something a little bit different and go through it, but I will answer a few questions now if anyone has them, any problems. If anyone has any specific questions, I can try and figure it out, or if they've had any issues, we can try and get those sorted, so let me know. But that's pretty much, I think, the end of the content itself. Yep, so we'll just hit into some Q&A and some practice. And if you're taking off, thanks so much for coming along. Appreciate it. These workshops will be uploaded in some way, shape or form. Yep, so the tables will work the same way as figures, in that you need to specify a H or a HT to get it appear where you're wanting to. So I think we had begin table like this. I'll just copy this over. Put a table in my conclusion. So here's my table. And yeah, table appears in a little bit of a weird spot. If I want it to include where I need to, you can include a H there. And that should make it go, although mine's split weirdly over a page. It'd be better if I put it up. Maybe here. Yeah. Don't forget, if you want it in the middle, don't forget your centering. Environment. If I wanted it left aligned, you can include also the vertical bar. So shift and then the key above enter in your where you have your column specifier. And that is going to include vertical lines in those columns that we specified. You can also include H lines. For doing horizontal lines to divide those up. I think H line and like V space. Let's go something big, 2 centimeters. So we can see it. I think that should do something. Yep, so we've added in some vertical space there, which may or may not be useful. You'll need to do multi-column and include the multi-column package. If you want to start like merging cells like you would in Excel, that's called doing multi-columns. Yeah, no worries, glad I can help. Let's try and do something. Today, let's try and typeset Maxwell's equations. Just for fun. So yeah, feel free to ask any questions. I'll just be working on some typesetting and sharing any hints and stuff as I come across them. Don't forget about Google and Stack Overflow in the future. Okay, so I think it's Nabla. Let's just see if I got that right for that symbol. Yep, so Nabla gives me the grad. C dot for center dots, and then Math BF for bold font for a vector. We'll render those with looking like a vector. Clear page is another useful command. Clear page is sort of like new page, except it will render figures that are pending to be rendered. Equals frac row on epsilon sub 0. Cool. What's the next one? Is there a way to change the font? Yes, there is. I don't know why you'd want to. I love, love, love the look of LaTeX font. It's what just looks nice. If you want to change the font, I think you can. I don't know how to do it because I never have. Let's see if there's any different tools. What does this give me? Font styles. Certainly I can get different font styles. I can do different size. I think maybe up in when you're defining your document class or something like that, you'll include it somewhere up there. It is possible, but yeah, you'll have to have a look. Someone wants to share the secret if they get into a sneaky Google, but you can do it. You'll run into potential issues about which fonts LaTeX actually has available. So, you know, you're not going to have probably access to like Comic Sans or something like that, thank God. But yeah, a few of the basic fonts are probably there. Now, I think in my, if I wanted to do vectors over arrow, maybe, or is it vec? Let's try vec for vectors and see if that works. Yeah, so \vec has given me a vector with an over arrow, which can be nice if you want to do it that way. You can nest, if I want that bold as well. Oh no, don't tell me. Oh no. Comic Sans in LaTeX. Oh. Well, I guess it's there if you want it. More power to you. That'd be funny to submit a LaTeX assignment all in Comic Sans. Grad B equals 0. Sorry, yeah, div.
Sorry, how did you get the B to look like that? Mine's looking just like a regular B.
Right, so, oops, that's broken. Over, so the first thing, Math BF is how to make it come
sorry,
up.
no, it was a different, like, but just before, in the last 10 seconds ago. The B was like it looked more like a beta than it did.
Right.
Yeah, now I've got the blended back.
Yep, I think that's my Zoom level. It's
okay.
Playing issue with that. Obviously, there's Greek letters if you want to do like /beta.
Yeah,
we'll give you an actual beta, and there's typically a capital letter on the first of the Greek letter will give you the lowercase versus uppercase. I don't think beta has lower and uppercase, but something like alpha should have a uppercase version. Nope, that's something with uppercase.
Delta,
that's a good one. Yeah, so there's a lowercase delta and there's an uppercase delta with a capital versus lowercase first letter. I think depending, like if you're smart, right? If you're doing a lot of vector calculus, you wouldn't be writing nabla times something else. You'd set up like a macro that's for a cross product that takes 2 arguments, and you go cross first argument, second argument. And then it would set up something, you know, you would put the first one and then draw your time symbol and then do your second one. You might format them as vectors if you're lucky, so you can get all that set up. So partial for partial derivatives. Like that. Let's copy, because there's something else. Maybe I'll do some integrals next. Yeah, that's all fractions and bolded, so I won't bother doing that last one. So align with the ampersand is what's called an align environment. So it's going to align my equations wherever I have the equals, wherever I have the ampersand sign. So in this case, I put the ampersand sign where my equal signs are, and that's going to make sure my equations are all aligned at the equal signs. I don't have to include them at the equals, if I included one of them, the alignment character right at the end, it's going to make sure all those points of my equations are aligned, right? So aligning the end of my equation with the other alignment characters, which is just before the equals in that case. But typically we like to align at equals. So there's an integral. I think, depending on how you want to format, I think technically the D in an integral should not be italic. No. So you might need to include that in text, but oftentimes you'll just do just dx like that. It looks okay. Yeah, that the asterisk suppresses the numbering exactly. Exactly right. So here's how I'd lay out an integral, being \int _0 will set the lower bounds to the power caret, and then whatever your upper bounds is, \infty for the infinity symbol. Do your integrand, and then I like to include this \comma. All that does, it just creates a little bit of extra space. It's like a pixel or two worth of extra space, like horizontal spacing there, which can be nice to separate your integrand from your variable of integration. Another one is \quad, which I think is 4 spaces of horizontal space in a math environment. There's q_quad, which will do double that, or q quad. No, we run out, just quad and double quad. But yeah, you can just include as many of those as you like for the, a set number of spacing, almost like a tab. So that can be handy. But yeah, for integrals or just a similar one, \comma will give you just that little bit of extra horizontal separation. What else do we come across in typesetting maths? Most of it probably have covered. Yeah, you just look through your list of characters. They're all sort of there. That's most of the common things: integrals, subscripts, superscripts, fractions. You can do for sine and cos. Obviously, pi is just \pi. For sine and cos, you want to start those off with a \. If you don't, it's just going to interpret them as the letters S, I, and N, like the variables S, I, and N, would how you interpret those squished up against one another. I mean, you still read it as sine, but it's not like sine or cosine. So always use the \, and that's going to just make sure they're correctly typeset for that. Obviously, I think there's like √2, like that. Yeah, we can take a quick look at ticks, and also in the last 10 minutes, I can probably do a Bibtex thing as well. That's a little bit more involved, or maybe we only have time for one, or maybe I'll do both. Any preferences, ticks or Bibtex? Forgot about Bibtex, sorry. Happy to do either or. Bibtex for referencing if you haven't clued on to that. It's a way to include all your referencing all in one spot. So Tix is a graphics package for doing simple vector, what do they call it? Scalar vector graphics, SVG style of line drawings and graphs and things like that. Let's see, I'm trying to think of whether I have an example from Tix that I can work from. I don't use Tix that often, so I don't usually create it all from scratch. I just grab a past example and use that. I probably have something in. Let me open up some of the other stuff. Nope. There's one. Okay, so here's some example of a Tix figure. So this figure has been created all within LaTeX in code. Same with this, this circuit diagram has been all created in code to make that. So I'll just have a look at the Tix stuff. So you need to include use package Tix to start with, and I'm pretty sure this just came from the Tix documentation. I just copied it straight out of there. I'll try and let me paste this in the chat for you guys if you want to try and get it going. I think the just be careful when you're copying and pasting that into your editors. That Zoom, I think, sometimes adds in random characters somewhere that don't necessarily work out okay. I might put up a oh, I missed the first backslash on the start of that begin too. Just beware. Here's probably a slightly better way. There's a link to a paste bin, which you can grab. But essentially, we start our Tix environment by saying begin Tix picture. Before that, we just create a figure environment in the same way that we do when we do like include graphics. So it works the same way. We can do centering and include the H flag to get it to come up here. So just breaking this down, a path goes from a node. So it's done in sort of like a virtual coordinate system. It doesn't explicitly create a coordinate system, but you sort of define your own coordinate system for the image. So imagine this is a node at 0, 0 of this coordinate system, at the origin of our coordinate system. So we go from this node 0, 0 using a line to the node 0, 5. Okay, so we sort of have to keep these up in our head, and you've got to have an idea of how this works. And then we go, these specify angles that come in and out of that node. So we leave the node at -80 degrees, and we go into the other node at 160 degrees, and they're referenced like our usual mathematical angles do. So counterclockwise from the origin going to the right. So negative going downwards clockwise and positive going upwards. And then we join that to the node at 3, 0.8, and join that to the node 3, 0, and then we join that back to the node of 0, 0. So 0 to 0,5, that is going from our origin here over to 0,5 over here. And then we're going, oh, sorry, we must be going to here maybe. I haven't looked at this example in a while. Or that could be up here. 0,6. Yeah, so I think that this first line here is defining the curve as a closed shape. The next line looks like it's joining the axes, maybe. Yeah, probably not the best example to start on, sorry. But if you can get that going, get that up and running, and there's the good TIX documentation, there'll be plenty of TIX stuff. But essentially, TIX is all about creating nodes on this virtual canvas, this virtual axis, creating nodes at certain points and joining those nodes with certain lines. So straight lines, curved lines, lines with arrows on them, things like that, and being able to label those points. But yeah, it's a little bit involved. If you're doing complicated figures, like if I was doing this, maybe I wouldn't use TIX depending on what I was doing. You'd generate this with an actual curve, because you don't define a quadratic to go to. You just define general shapes that the figure looks the way that you sort of want to. I think another place that I used it was in, I used it a bit last semester in, let's see if I can pull one up. Maybe workshop 4 has one. So drawing finite state machine diagrams, moving between states. So that is, there's a package for it, but at its core it uses TIX. So you're defining things lying on nodes and how the arrows join the nodes together. You can define curves. So if we have a look at the code that generates that, it's sort of here. So a state at the node -1.5, 1.5, with a circle, and then at the 1.5, 1.5, 1.5, -1.5, and -1.5, -1.5. So that's my 4 points on that grid, and they're labeled on the inside like this, and then I draw my transition arrows like this from a particular point traveling towards another point. And yeah, there's different ways. There's like absolute and relative style referencing, which can help change things a lot. So essentially a TIX picture will look like this, joining nodes with arrows and lines. Okay, and I'll just spend the last few minutes. I'll quickly try some, I'll try a Bibtex thing, see if I can get some, try and get some Bibtex coming up. Yeah, complex but useful, exactly. If you're doing a complicated figure, like mostly you're making your figure in MATLAB or something like that. Now, I might not have the best Bibtex workflow. I don't use Techmaker's inbuilt sort of Bibtex stuff. What I do is open up my tech distributions bibliography editor called Bibtex to actually create the site and the reference sort of format. So that will be, a site key is what we want to use in our document for referencing. And that might be, you know, fave article. just something that you can do. So the author could be me. The best article. Right, and we save that. And that we need to save to the same place in your, like you would save an image in the same working directory. I call it references.bib, but you can call it whatever you like. And then you can start building up your different references by adding in different things to that. If we have a look, right, all that's doing, if I open up this references.bib file in a text editor, all it's doing is it's just plain text with a certain format that then LaTeX knows how to use. So you can create this just with plain text, right? You don't need a bibliography editor, but they can make it a little bit easier to do. Then to reference something, we need to include the bibliography package, I think. Down the bottom, let's clear the page. We tell it to create the bibliography like this, I believe. Usually all this I've got set up in my template, so I'm real rusty on this. And then in the text, all we need to do is just cite whatever I called the cite key in that article. So fav article like this in my text. And then if I've done it correctly, I probably haven't. Bibliography.style. Yeah, you have to build the bibliography first. Let's see if that works. Nope. Let me see what I've done wrong. I can never remember this stuff. I think I've got one in my recent assignment. Not that one. Sorry, bear with me 1 second. Probably better off Googling at this point. Let's see. Yep, okay, I need to include the file that I called my bibliography. Maybe that will work better now. Build the Bibtex. Nope, still not getting it right. No worries, thanks for coming along. Bibliography style that I've missed. Yeah, probably better off looking for a tutorial at this stage because I'm just digging myself in a hole. Yeah. Yeah, not getting it. It's all set up somewhere else, but obviously not playing nicely for me at the moment. So yeah, unless there's any other questions, we'll probably leave it there. Oh, I got it. I think I got it. Undefined references, build the... Sometimes you've got to build things a few times to get it to work. It's trying its hardest. Almost got it. Yeah. Anyway, we'll leave it there. Rightio. Thanks everyone for joining. And yeah, I'll try and get these the recording up at some point. And I'll catch you all later.